Greetings everyone. As always, I would like to start with a brief disclaimer. These videos are meant to help people learn physics. At times, it's meant to provide helpful hints, and at other times, it's meant to take you through the entire problem with hopefully what is a decent explanation so you can solve many others on your own. I try my best not to show the entire answer in any one screen so that the video remains about learning how to solve the problem and is not something simple that can be used as a shortcut to cheat or get ahead. If you're putting up with the sound of my voice, clearly you must want to learn this material. Okay, let's get started.
So this is a really fun problem. We have two stars. Let's get the pen size right. Okay, we have two stars. They are of equal mass. So here's star M and the other star M. Two stars, binary means two star system. Let's say the center of this, that's the midpoint, and then the center of this. So they are observed to be separated by 360 million kilometers, right? So let's just assume that separation is center of mass to center of mass. So this is 360 million, meaning 10 to the power of 6. And they say kilometers, so I'm just going to say 10 to the 3 meters. That's how far apart they are. And really, this is a radius. You might consider the center of gravity to be here. This is a radius, and this is really 2 times the radius. This is the diameter. Is the distance between them is the diameter. Hope that makes sense. Okay, so the next question is that, well, their next piece of information is that they take 5.7 years to orbit around a point midway, right? What is the mass of each? So what else do we know about it? Well, the orbit length, right? Because the orbit is going to be, just going to assume it's a circular orbit, right? And how do you, any circle, the circumference is 2 pi r, right? Now, another way to write this is pi times 2r. And guess what? 2r has already been given to us. So that if we want to find the circumference of the radius, the distance traveled by those two stars, it's basically substitute 360 times 10 to the 6 times 10 to the 3 meters here. So just 360 times pi times 360 times 10 to the 6 times 10 to the 3 meters. This is the distance traveled by the two stars. Hope that makes sense. Okay, so now we know the distance. This is the distance. We know the time. Time is 5.7 Earth years, right? And so speed is something we can find out about this. Just not trying to do anything clever, just saying this is what I know. Speed equals distance over time. So just rolling with it. 360 times 10 to the 6 times 10 to the 3. I'm going to leave out the units. I'm not going to write meters. And 5.7 years. So 5.7 years. So that's 3.15 times 10 to the 7 seconds are present in 1 Earth year. So that should cancel out, and now you'll get seconds, right? So then you'll end up with meters per second. I know I said I wouldn't put units here, but I ended up doing it anyway. And if you do the math on that, you end up with 0.630 times 10 to the 4 meters per second, and that makes no sense, so let's just 6.30 times 10 to the 3 meters per second. You can write that as 6.3 kilometers per second, or you can write that as 6,300 meters per second. It's completely up to you. So now that you have something nice rounded off, you know the speed, now we kind of get into the question. What is the mass? Oh boy, how are we supposed to know the mass? We know the speed. What else? Oh, we know that circular motion, there's this force that we often talk about, and it's not a real force. The real force here is the force of gravitation, but you can predict the amount of force using this equation for radial force using mass times velocity square over r, radius, right? And in this case, whatever this is, f of r, is basically whatever the force of gravitation is. They must be equal, right? Because this is just an observed, this is just a way to model the force, and this is the actual physical force. So the magnitude of these forces must be equal. So I can continue writing mv squared over r, which is radial force, is equal to force of gravitation, which is, the masses are exactly the same. So by the way, I'm just going to use capital M. Here it's m times constant g over r squared. So m times m is m squared, but 1m cancels out, 1r cancels out. So I'm left with v squared equals 1m times the gravitational constants. Actually, let's take another look at this. I'm probably 2r. Oh, no. The distance between them is 2r, so it's 2r squared. So while the r cancels out, the 4 still gets multiplied. So I end up with 4r, right? Why? Because at the bottom is the distance between the center of masses of the two things, which is 360, which is 2r, not the radius. The radius is for the radial force. So v squared equals m times g over 4r. If I did a bad job of that, I'll just start again. Force of radial, what's the equation of that? mv squared over r. Gravitational mass times gravity times the distance between two objects, that happens to be 2r squared. And if you carry on with that, mv squared over r equals, capital M, m squared times g, 4r squared, 1r goes away, 1m goes away, and again you see v squared equals m times g, 4 times r. Hopefully that makes sense now. If I didn't do a good job here, hopefully explained it here. Now what do? Well, we want to know the mass, so let's just get mass on one side. M times g equals v squared times 4r. So m is equal to v squared times 4r divided by g. And if we put in the numbers, we know the velocity, 6,300 meters per second, right? We know the radius, it's half of 360, and we know g, which is a constant. And we put that all together, we should get something like, 4 times 6,300 squared times radius is, the radius is 3.60 times 10 to the 11. And actually it's divided by 2, and g is 6.67 times 10 to the negative 11, and 1 and a 2, and you solve for the whole thing and you end up with 4.29 times 10 to the 29 kilograms, because mass is in kilograms, and if you kept track of all the units, you better end up with kilograms, otherwise we did something horribly wrong here. So there we go. Now we know the mass of each star is roughly 4.3 times 10 to the 29 kilograms. Pretty cool problem. Thanks for watching.